Today's seminar is going to focus on slope-intercept form. So the goal of our lesson, or our I can statement, is I can explain that an equation in the form of y equals mx plus b represents the graph of a linear relationship with a slope of m and a y-intercept of b. At this time, if you could pause the video here and go ahead and write this goal in your notebook, as well as the title of the lesson. Alright, so first you're going to need this foldable here that talks about slope-intercept form. And the things that we'll be looking at here today are slope and intercepts, writing equations in slope-intercept form, and graphing using slope-intercept form. So let's go ahead and get started here with our first part, which is slope and intercepts. Now, before we do the top part here, I want to talk a little bit about the equation down here below. Alright, so slope-intercept form. We know slope-intercept form as y equals mx plus b. Now let's talk about a couple of parts here. So first and foremost, it's going to be determined that we're going to move along our line. Remember, our change in our y over our change in our x. M is going to represent slope. And remember, slope is your rise over run. And we could also say this is equal to your y over x. And the second important variable in this equation that we're going to have to look at is b, which is known as our y-intercept. And this is where the line that we graph is going to cross the y-axis. It's also going to be our starting point when graphing a line, but we'll get into that a little bit later. Now your x and y are going to be your input and your output. So different points or coordinates along the line that we could plug into here to see if it does fall on this line, depending on what it is. So that's just the first part of our lesson here, identifying the different parts of the slope-intercept form equation. This is something that I would start to commit to memory, as you will be using a lot this year and in the future. So let's go back up to the top here then. One important thing that we really have to focus on is being able to identify what our slope is, as well as our y-intercept. So let's go ahead and do that. So our directions here say identify the slope and the y-intercept in each of the graphs below. Compared to the equation of the line, what do you notice? So our first thing here that we have is the graph below represents the linear equation y equals 3/5 x minus 2. Now if you think back down to our equation here, remember our slope is going to be the m value, or whichever value is next to your x variable, and your y-intercept is what's either added or subtracted over here on this end. So let's go ahead and write these down. So looking from the equation here, we have 3/5. We know that's going to be our slope because that's our m. And our y-intercept is actually going to be what's subtracted here at the end, the -2. And realistically, this is really a coordinate at the point 0, -2. And your y-intercept will always take that form. Now let's compare this to our graph up here and see what's going on. So, if we were to start, we would find our y-intercept first, which is here, at 0, -2. You can see that correlates here to what we wrote down. And if we think back to our slope lesson with rise over run, moving between these points, we can see that we go up 1, 2, 3. You can see that there, kind of. And we go to the right 5. 1, 2, 3, 4, 5. So we can also see this from the graph. We can write it from the equation as well as from the graph. But the easiest way to identify these is just to look right at your equation. Like I said, the value next to your x variable is your slope, and whatever is added or subtracted after the x variable is your y-intercept. So go ahead and take a second and try to identify the slope and y-intercept of number 2 here, and then see if you can see the relationship by working through the graph. Okay, so you should have tried this one. So our slope is negative 1/2. And our y-intercept is 3 or 0.3, we can call it as well. Same idea there. So let's go ahead and look at this real quick in relation to this graph. So our y-intercept is where our line crosses the vertical y-axis, this one here. And that's at the point 0.3. And you can see that it crosses right there. So I'm just going to mark that point. And then if I do my slope from there, the down 1 and the right 2, I'll see that I end up on this dot here actually. So down 1 to the right 2, I'm back on that point. So we can see just how this equation lines up with the actual graph of it. So that's what slope-intercept form looks like and how we can identify the different parts of it, different parts of the graph or the line from this equation here. So let's go on to our next section here and talk a little bit about writing equations in slope-intercept form. So we're going to be doing exactly what we did previously. Just zoom in here real quick. All right, so problem 1 and 2 here. We want to identify the slope and identify the y-intercept. Now we're going to have to do this from the graph, so we're going to have to remember how we find slope from a graph. First and foremost, I would find my y-intercept. Remember, that's the point at which the graph is crossing the y-axis. So at the point here, let's see, on my y, if I move, I'm going to go down 1, 2, 3. So I see that this is negative 3. And that's what we'll have to subtract at the end here. So I just want to include here as well that the coordinate of this would be 0, negative 3. We won't need that to write the equation, but that's important to know. Now let's start from this point here, my y-intercept, and let's figure out what the slope is. So we would go up 1, to the right 1, 2, 3, 4. So it looks like my slope is up 1 to the right 4. So it looks like it's 1/4 there. And if I'm looking at this line, if I were to walk across this graph from left to right, I see that I'm going uphill. I know my slope is positive. So there's another relationship to the last lesson that we did, knowing whether it's positive or negative, that this answer is positive, so my slope should be positive. Now, let's go ahead and write the slope-intercept form version of this, which will be y equals, that will always be a part of your equation. Then my slope would come next. If you think back, m 1/4 x, and then my y-intercept is negative 3, so I would write minus 3 there. You're just filling in the slope and the y-intercept. So y equals mx plus b, we filled in the m and we filled in the b. And the y and x are always there because that's like a coordinate that you could put in there. My input and my output. And whatever you put in there should fall somewhere on that line. Let's take a peek at number 2 before I have you try some of these on your own. So first I'm going to identify the y-intercept. And in this case, it looks like it's the point 0, 1. So my y-intercept is just going to be 1. But like I said, we can make note of the y-intercept. You can see it's there. The exact point where it's on this vertical axis, your y-axis, 0, 1. And let's figure out our slope from there. So you could start from any of these points. Like I said, if you want to start from the leftmost one, you want to see your rise over run. So I'm going to see how far I have to go down first. 1, 2, 3. And since I went down 3, I know it's going to be negative, and I need to go to the right 1, 2, 3, 4. So I know my slope is negative 3/4. So let's go ahead and write our equation then. Like I said, y is always a staple, equals always a staple of this equation. Then my slope would come, negative 3/4. And since this is a positive 1, where it crosses, I forgot my x, you need your x there. And then I would say plus 1. Now what's cool about this is I can go back and double check and make sure that this is the correct equation. So I would start at the y-intercept at 0, 1, and I would go down 3, because now I'm going to follow my slope, my rise over run, 1, 2, 3, and I would go to the right 4. 1, 2, 3, 4. Okay, so I landed on that point. I know that I have the correct equation of this line. Also, it's a negative slope. So if I walked across this line, it would start high, or if I walked across this graph, I should say, and I walked along the line, I'd be walking downhill, so I know it has to be negative. I want you to go ahead and try number 3 and 4, and then go ahead and watch the video and I'll explain what's happening here. So go ahead and pause it and give these two a try. Okay, so you should have given these two a try. So let's first and foremost on number 3 figure out what our y-intercept is. Remember, that's where your line is crossing your y-axis. Excuse me. So it looks like it's at 1, 2, 3, 4. And this would be 0, 4. And then my slope, well, let's start from the y-intercept and figure out how this is moving. So rise first. So it looks like I'm going down 1, 2. So I'm going down, that means it's negative over 1. And that pattern should fall all the way through. Down 2 to the right 1. Down 2 to the right 1. As you can see, and sorry my marker's not showing up very good, but if you go down 2 and over 1, you can kind of see that it falls on the line. So let's go ahead and write the equation for this then. What I should get is y equals, you can keep negative 2 over 1 to remind yourself that you need to move to the right one when graphing this, but typically you're going to see this as just 2, negative 2x plus 4. That's typically all you're going to see at this time. Because we know this is a whole number, and we typically don't write whole numbers over 1. But if you want to remind yourself for now, you can put this over 1. That's completely fine. Nothing wrong with that. So your equation for this one should be y equals negative 2x plus 4. All right, number 4. So this one's a little bit trickier. Your y-intercept here is actually the origin at 0, 0. So your y-intercept will be 0, and that coordinate would be 0, 0. The slope we can do just like any other one. So if I start at my y-intercept, I need to go up 1, 2, and I need to go to the right. So 2 I'm going to put. I need to go 1, 2, 3, 4, 5 to the right. So my slope is 2/5 here. I don't like how that looks. 2/5. From there, you should be able to write your equation. Y equals 2/5 x plus 0. Now, really, you could also write this just as y equals 2/5 x. Same thing. Typically, you're probably going to see it like the bottom one, so you'd need to know if you were graphing this that you'd plot your y-intercept at 0, 0. Okay, so that's writing equations in slope-intercept form from a graph. You could also do this if you were given the slope and the y-intercept. You could absolutely write them. So let's take the next step in this process then, and let's talk about graphing linear equations using slope-intercept form. So this process is pretty straightforward, and I'll show you exactly how to do it here. So you have a couple steps that you have to work through whenever doing this. First one is going to be to identify the slope and y-intercept. So looking at our equation, let's go ahead and do that. So I'm going to just use m for slope because that's what it represents. And remember, m, or the value next to x, is what your slope is. So this is 2 over 3. And my y-intercept, which is, in this case, it's negative 1. You should always take the sign that's in front of it. Okay, so this is negative 1 for my y-intercept. And it's going to be important to know the coordinate here of that, 0, -1. So step 2 is to plot the y-intercept. So at 0, -1, I'm going to plot that. Try to make it big enough so you can see it. And then finally, step 3 is use the slope to plot 2 additional points starting from the y-intercept. So from where we started, we have to move how the slope tells us to. In this case, it would be up to, remember this is your rise over your run, it would be up to and to the right 3. 1, 2, 1, 2, 3. Okay, so that would be my next point. Now, the rule for making a line is that you need 2 points to form a line. But when you're working with slope-intercept form, I want you to plot 2 points in addition to the y-intercept to make sure that you're on the right path. So I'm going to go ahead and do that. So I can go from this point that I just did and go up to 1, 2, so doing the slope again, and to the right 3, 1, 2, 3. So typically we're always going to move to the right, but I want to show you something here in case you ever run out of graph, which you might do, and you might have to work backwards. So starting from the y-intercept here, instead of going up to, I'm going to go down 2, and instead of going right 3, I'm going to go to the left 3, and this should still fall on the line. So this is a case where I need to move backwards. So I'm going to go down 2, so the opposite of what it told me, up 2, and the opposite of going right 3 and going left 3, 1, 2, 3. Now that might seem confusing, but that's definitely something that you are going to have to do sometimes. Moving to the left typically won't happen, but like I said, it might show up. Last but not least here, you need to use a straight edge to connect all your dots that you plotted. Really, you only need 3 dots, but I showed you going backwards, so we have 4 here. So run a line through those using a straight edge, please, and it should cover the entire length of the graph, and then throw arrows on the end of that to indicate that this line is going on forever, because that's what it's doing. So let's go ahead and try a couple more down here then. Remember, your rules are right above, so in case you forget what to do, you can always refer back to that. So step 1, let's plot our y-intercept, -4. So this would be 0, -4. 1, 2, 3, 4. So I'll make that nice and big so you can see it. And then from there, it's telling us our slope is up 1 to the right 3. So up 1, 1, 2, 3, plot. Up 1, 1, 2, 3, plot. And that's plenty of line there, or plenty of dots there, to make sure that we have the line. And it looks like they're following the same pattern, so we can go ahead and throw a line through that. Remember, make sure it goes the whole length of the graph. Put arrows on the end, and that's all you need to do. Let's try number 2 here. Y equals -5x plus 3. So, first and foremost, we need to plot our y-intercept, which will take the form 0, 3. If you've noticed, your x value is always 0 because we're not moving on the x at all, we're just moving along the y-axis. So let's plot 0, 3. 1, 2, 3. On our y-axis, this should always be plotted on the vertical axis at some point, whatever it tells you. And from there, my slope is -5 over 1. So remember, rise over run. And we need to go down 5 from there, because that's our rise. 1, 2, 3, 4, 5, and to the right 1. And from there, we're going to do the same thing. And it looks like we're going to run out of space, but we'll just eyeball it. 1, 2, 3, 4, 5 over 1. So 3 points I want you to do. Get your straight edge, put a line through there, and you should be good to go. Arrows on the end to show that it's a line going on forever. And what I'd like you to do is try 3 and 4 on your own. Now there's a little bit of tricky stuff going on here with these ones, but give it a shot. And once you've tried them, go ahead and play the video and I will talk through them. So first and foremost, with number 3, it looks like there's nothing in front of here. But if there's just one x, that means there's a 1 in front of it, and that's over 1. Okay? So our slope here is 1 over 1. But first, we want to plot that y-intercept at 0, 2. So let's plot that, 1, 2. And from there, our slope is telling us to go up 1 to the right 1. Up 1 to the right 1. Up 1 to the right 1. Let's kind of review what we talked about before as well, that if we ever need to move backwards, we're just going to do opposite of what the slope tells us. So we could go down 1 and to the left 1, and it should still fall on that line. So we have enough points here in order to draw a line through. Remember, always use a straight edge, extend it the length of the graph, arrows on the end, and you're done. Number 4 here, what you need to do, as we see there's no y-intercept, so that means it's just plus 0. And that is going to be at the point 0, 0 on your graph. So right at the origin, right in the middle. Our slope is 3 over 1. Remember, that's rise over run. From there we need to go, so what it tells us, starting at the origin, remember that's where we want to start, up 3, 1, 2, 3, over 1, 1, 2, 3, over 1. We could also go backwards, down 3, 1, 2, 3, to the left 1. And it should still fall on that line. Like I said, get your straight edge, draw a line through there, and you're good to go. So that's graphing in slope-intercept form. We do have one other thing that I want to cover, and it's special cases when graphing lines. And that's going to be if you have a horizontal line or a vertical line. So you have a second foldable that I made for you. And it looks like this. I cut mine out. You can too. It doesn't have to be. It should still work in your notebook just fine like this. Let's go ahead and talk about vertical lines first. Okay? And we have a little saying here kind of that can help us remind us of what we need to do when we have a vertical line. So V for vertical line, the slope is always undefined. No matter what, this will always be undefined. And your equation will always be x equals something. So let's just say, for instance, x equals a. And a can stand for any number. For this, like I said, slope m is going to be undefined. And like I've said before, just kind of a rule of thumb here, you can't walk up a vertical wall unassisted. Right? I can't just walk up to the wall and start walking up it. Just won't work. And the equation for these is always going to be x equals something. Okay? So in this case, let's just look at x equals -2. And this is going to, it's going to crosses the x-axis at the point -2. And it's going to be the point -2, 0. So although this is a vertical line, it's plotted on the x-axis because the line will go through it. It sounds kind of counterintuitive, it doesn't make sense, but that's what it needs to do. So I'd plot this point at x equals -2 at 0, -2, 0, like I said. And at that point, it's just going to be a vertical line through it. At x equals -2. That's all you need to do. So it has one point plotted and just a vertical line through it. So if you ever see x equals, it's a vertical line, its slope is always undefined. So down here, like I said, if you ever see x equals something, slope is always undefined, and it will always be a vertical line. Let's take a peek at horizontal lines then quick to wrap up this seminar here. So this is HOI, or horizontal line. It will be the slope is always 0, and the equation is always y equals something. So y equals a, where a could represent any value. The slope of this, m, will always equal 0. It's like walking on a flat surface. We're not going up or down. And the equation will always be y equals something. So let's say y equals 3 here. And your point will be 0, 3. It's kind of like a y-intercept. And it's going to crosses the y-axis at 3. So what we would do here is plot a line at 0, 3. So I'm not moving on the x at all. It will be on the y. 0, 3. Plotted that. And then it's a horizontal line through that point. So let's go ahead and do that quick. That wasn't the best job, but it'll do. So at 0, 3 is where that would be. So like I said, horizontal lines will always be in the form of y equals some value, and its slope is always 0. And just as a refresher, if you have a vertical line, the equation will always be x equals something, and the slope is always undefined. You can see that here. So just a couple examples there for you to work off of. Remember that you should be putting your foldables into your notebook, glue them down, tape them down, whatever. They're there for your reference. You'll be referencing these a lot because you'll be doing a lot with slope in ALEKS and in class here. So make sure those get in there, not just in a folder, taped or glued in your notebook. And just as a recap, our goal for today and what we were working on, we looked at slope-intercept form. Excuse me. The goal or I can statement was I can explain that an equation in the form of y equals mx plus b represents the graph of a linear relationship with a slope of m and a y-intercept of b. Now, after watching this seminar, if you have further questions, please come and ask me. I'm always willing to help. Otherwise, this should be a good guide as to how to work with slope-intercept form.